Welcome to a simple, easy to understand explanation of Bayes' rule. This rule might sound complex, but we are going to break it down step by step so you can grasp its concept with ease. Let's start with the basics. Probability is like a fancy word for the chances or likelihood of something happening. When we roll a dice, there is a 1 in 6 chance of getting a specific number. It's like saying there is a 50-50 chance of rain tomorrow. Probability is all about measuring how likely things are to occur. Let's talk about conditional probability. It's just a probability of something happening when we know something else has already happened. Think about it like this. If you have a drawer of red and blue socks and you know that you have already picked a red sock, the chance of picking another red one has changed. Imagine you have a drawer with red and blue socks. The drawer contains 4 red socks and 6 blue socks. You are going to blindly pick one sock. Initially, without knowing which sock you have picked, you might assume there's an equal chance of grabbing either a red or blue sock. So, the probability of picking a red sock is 4 out of 10, and the probability of picking a blue sock is also 6 out of 10. You blindly pick a one sock and it turned out to be red. What happened to the probability of picking another red sock now that you have this naive information? Your initial belief that probability of picking red sock is 4 out of 10 has changed because you know that first sock you picked was red. Now, with one red sock already chosen, there are only 3 red socks left in the drawer and a total of 9 socks. So, the probability of picking another red sock is 3 out of 9. It's lower because there are fewer red socks left relative to the total socks in the drawer. In this practical example, the condition probability has changed based on the outcome of the first draw because the events are dependent. The first draw affects the composition of the drawer for the second draw, which is where conditional probability comes into play. This is more accurate representation of how condition probability works with the real world scenario. So, we are going to explain the power of Bayes' rule using a real life medical diagnosis scenario. Bayes' rule help us make better prediction and decision when we have new information. Let's dive in. Imagine you are a doctor and you have a patient with symptoms that could be related to a rare disease. To start, you have some initial information. The probability that a person in a general population has this rare disease is 1 in 1000. So, probability of having disease is 0.001. The chance of getting a positive test results if a person has a disease is high, say 0.99. However, if a person doesn't have the disease, there is still a chance of getting a false positive result, which is 5%. So, the probability of having false positive results is 0.05. The patient take the test and the results come back positive. Now we want to know the probability that the patient actually has the disease. Let's start with the Bayes rule. This is the formula for our condition. First we have to calculate probability of positive test, which is the total probability of getting a positive test results. Using this formula, you can calculate total probability of getting a positive test results. We already know the probability that the person in the general population has this rare disease is 1 in 1000, so 0.001. And we already know the chance of getting a positive test result if a person has a disease equals 0.99. And if a person doesn't have the disease, there's a still chance of getting a false positive result equals 0.05. So, what is the probability that a person in a general population has not this rare disease? We can calculate that using probability that a person in a general population has this rare disease, because we already know that one is 0.001. Therefore, probability that person in a general population has not this rare disease is 0.999. Now we know all the values that needed to calculate total probability of getting positive test results. Let's calculate total probability of getting a positive test results. We got probability of getting positive test results equal 0.05095. Now we can use Bayes' rule to calculate probability that the patient actually has the disease. So, even though the test came back positive, there's only about a 1.94% chance that the patient actually has the disease.